Good day. My name is Artyom Zhukov. I'm work as technical product manager and energy analyst in Remak team. I'd like to show you our analysis of a prototype, a new product, fancoil fCube, and we did energy analysis and optimization of control strategy and comparison with active chill beam and average fancoil. So this should be quite interesting to you. What is average fancoil unit? We pick data from Eurovent and provide statistical analysis. There is new 1000 units. And find characteristics of main components of fancoils like pressure drops of coils, efficiency of fans, and use this data to define average fancoil. And active chill beams, there is only difference in injection coefficient, but it is just the demand of the design decision. And copper values, just remember, yes, it is coil output to primary airflow ratio. Yes, it's hard to memorize. So it means how many watts of cooling it provides per 1 cubic meter per second of primary airflow. And we pick some average value for that, but it is the only question of price, so it is not efficient because active chill beam just passive component and do not consume any energy and use energy from the air which was energized by air handling fan. So we assume some simplistic 3D model, 3D geometry of office building with windows to wall ratio at 40%, and also in order to highlight advantages of these different types of terminal units like active chill beam or fan coils, we split in analysis into two categories. Category with variable air fresh air volume and constant fresh air volume, like in general good practice and at active chill beam category. And also it's important that active chill beam was in variable fresh air volume was provided with constant total air volume, but different percentage of recirculation and fresh air in economizer of air handling. Characteristic of construction envelope of the building was described here, climate here, design day in here. Inputs files are also obtained, put inside this document, so you could download it, put it inside Energy Plus software and see all details and make a calculation and adjustment just like you want. So if you want to modify climate or any another input parameters. So this is a typical system of air handling with rotary wheel, DOS, supply DOS, extract, boiler, chiller, all parameters are specified. The same thing. So FCU, CAV, FCU means fan coil unit, CAV constant air volume, VAV variable air volume with variable terminals, VAV. Active chill beam CAV and active chill beam in VAV, we call it recirculation, so this is damper modulate amount of fresh air. Specification of internal load for building, which we take, it was from good practice. This is a detailed specification of all equipment and parameters of it, which we took inside, and schedules as well, which we took inside the analysis. Validation of our results. So we find from Department of Energy, United States, we find similar buildings applying filters. So it should be office with such type of system, and climate was took as well similar. This is just a sample of 2 diagrams of cooling capacity demand of for coils. This is for fan coils. This is for air handling. So this is cutting edges is because of free cooling operation. This is the same, but for heating. This comparison, it will be accumulate into one table after that, so I not stay on this. So what we have next, we have that this is one. This table VAV means category with VAV and rec as well. CAV category with constant air volume, fCube, baseline fan coil, it's average one, and ACB active chill beam. So as you can see that the best here is quite fCube. No, the best is active chill beam, a bit less, but fCube with VAV is quite near. After that, we will see 6% difference. This is a number for that, so you can calculate any difference. And also, we notice that the biggest contributor of energy to annual energy consumption is in system with fan coils with standard control strategy is fans of fan coil because of its inefficiency, and we could program another control strategy for fan and reduce its operation and consumption at near 8 times, as you can see here. In standard control strategy, it was 48 megajoules per square meter. After optimized control strategy, which shift the energy consumption from fan to more cold air and chiller. So we always put more energy to chiller rather than to fan. This is the idea of optimization, but it's much more sophisticated. And as a result, we've got that fCube with optimized control strategy consume at, I will show after, at 30% less energy than active chill beam, and at 35% less energy than fCube with standard control strategy. Moreover, because of coils, parallel coils allocation, fCube could be installed, extract air only from the ceiling space. So there is almost impossible to connect any plenum to it and extract air from the room space. So there should be consideration about temperature of extract air corresponding to the room air. And this graph shows that blue line curve is room temperature, orange is extract temperature in the premise. So 1 degree higher, but in terms of annual energy consumption difference, it has almost nothing different. So there is a lot of factors. If you're interested in it, you could contact me personally, because it took a lot of time to explain. So this is a resume of our analysis of the percentage difference. For instance, in standard CAV category, fCube more energy efficient than 24% than baseline fan coil, less energy efficient than 46% than active chill beams. Gas is quite similar. In VAV category, it's a bit more energy efficiency, and please note that it is all electricity consumption wall system, because in case we compare only fan coils, our fancoil at 50% more energy efficient than baseline. And with adjusted control strategies, I told you already 35% more energy efficiency than fCube with standard control strategy and 30% an active champion. So they're much more energy efficient. So the span is high and still bigger potential to optimize it because of inefficiency of fancoil fan. This is influenced to Bremen LEED or another sustainable certification because the most important parameters is energy consumption or the construction. So you easily implementing fCube, you easily could get to from 2 to 3 point credits. Bremen 3.5 for LEED. It's very good. There's some statements for analysis. So thank you for your attention. If you have any question, you could contact me personally. I will leave somehow my email. Have a nice day. And thank you for being with the Remak team. Bye.